Alright guys, this is the second round of videos on how to solve these word problems. This is from 2.3a, and again, you should solve it and then watch it, and if you're stuck, then watch it and then solve it. Now guys, we're looking for keywords and conceptually understanding what is going on so we can write an equation and solve it. Your lunch period lasts for 1/2 hour. You eat your lunch for about 2/5 of that time. Did I say 2/5? 2/3 of that time. What fraction of the hour do you spend eating? Well, we want 1/2, right, of that 2/3. Is that right? Let's see here. Nope, I wrote it backwards, because watch. Your lunch period lasts 1/2 hour. You eat your lunch for about 2/3 of that time. What fraction of the hour do you spend eating? So we have a 1/2 hour, and we actually want 2/3 of that. The nice thing is that multiplication is commutative, which means you can multiply it either way and you'll get it right. Division is not. I cancel that out, and I would get 1/3. Let's double check that. 18. 1/3 hours. And there you go, 1/3 of an hour. All right, next one, 19. In a baseball card collection, 1/6 of the cards are for players who are retired. Of those, 2/5 have been retired for less than 5 years. What fraction of the players' cards are players who have been retired for less than 5 years? So we have 1/6 of the cards. A baseball card collection, 1/6 of the cards are players who are retired. So 1/6 of it are retired. But of those, 2/5 have been retired for less than 5 years. So we want 2/5 of 1/6, which is 2/30ths, or simplified as 1/15 players. 1/15 of the players. I hope I'm on the screen. Looks like I'm flying off. I think we're good. Next, 2/5, it's all right, 2/5 of the students in your class are in band. Of those, 1/4 of them play saxophone. So 1/4 of 2/5 play saxophone. So I'm going to write saxophone right there. Oh, phone. What fraction plays saxophone? All right, so let's multiply that out. That's 2/20ths, or 1/10. So 1/10 of them play saxophone. And then what's the next question to ask? There are 30 students in your class. How many students in your class play saxophone? Well, I want 1/4 of, is that right? No, that's not right. Well, we know that 1/10 of them play saxophone, right? So then what is 1/10 of 30? Well, that's multiplication. Cross cancel. 3 of them play saxophone. So 1/10 of them play, if I kept it in fractions, but 3 players actually play it. And this is where the of comes in very handy. You see how we keep using of? Very handy. Next. Let's take a look at this. And as you can see, I've already have a little work on here. Why? Because I'm going to be honest, some of these word problems, they were a little intense, and so I actually had to think about them for a little bit. So I'm going to cover that up. All right, we'll get to those in a minute. I don't want it to be a distraction. First, evaluate. Evaluate is synonymous with solve. So look at these. These are, they have 3, what's the right word? They have 3 terms in the expression. And this takes us back to PIMDAS. If you're like, how do I solve these? I would go, it's not so much what I would do. You need to use order of operations. And here we have divide, divide, so we would go left to right. So what you would do is you would solve that, and then divide it. So look at this one. Do we add or divide first? Well, according to order of operations, we would divide first. So you would divide and then add. Look at this one. According to order of operations, you would do what's in the parentheses first and then multiply. So this is a nice little review on order of operations. And be sure to follow that. And it's being applied to what? It's being applied to fractions, which is something we have been really working on. Okay, let's work on these next problems. I'm trying to find my answers. I can't find them. How many times larger is a 10-pound dog than a hamster weighing 5/8 pounds? Now look at this. How many times larger? Here's your clue. And so let's pretend here is the dog. Ooh. Well, we're just going to have to make the dog look like a cylinder. Why? Because it's easier to see. So here's your dog, 10 pounds. And here's your little hamster. And your hamster is pretty small in comparison. Here it is. See that? And it's just 5/8. And when it says how many times more, they literally want to know how many of these hamsters does it take to constitute or equal this dog. So this is 10 divided by 5/8. And we don't divide fractions, we multiply by their reciprocal. So those cancel out. So the dog is literally 20, not 20, that should be a 16. 2 times 8 is 16 times bigger. That much bigger. That's why rodents run from dogs and cats. And let's make sure we did that right. 10 divided by 5/8 multiplied by the reciprocal cancels out. Yes. Keyword, how many times larger? Okay. Let's try this next one. This next one, I almost just didn't do it, but I think you can work it through. So you should have tried to solve this. You have the answers, and you probably discovered, wowzers, this is a tough problem. And you know what? I said wowzers to myself, and I said, wow, this is a tough problem. But I'm going to show you how you can solve this using what you know. So here we have a digital, and so you can see I'm sketching because I'm trying, not sketching as in freaking out, but sketching so I can see what it looks like. And a digital camera memory card is 1/4 full. So here it is. Here's 1/4 full, okay? And then, so I wanted to see what that looked like. And then the card is 2/3 full. So here's the second idea of the card. 2/3 full, and I put that in yellow so you can see it, when 375 more pictures have been added. Yikes. What does that mean? Now, the reason why this is hard is really what they're saying is this, is 1/4 of the memory equals 2/3 of the memory plus 375. And they're actually asking you to write, oh, that's not 75, that's 57. I keep doing that. They're actually asking you to write an equation for it. But have we gone to equations yet? No, we're not starting that till in late January. That's why this thing is so trippy. So let's go back and start over and solve it in a way that we can solve it. So let's ignore my equation and let's look here. A digital camera memory card is 1/4 full. So I show you what that looks like. The card is 2/3 full. Here it is, 2/3 full when 375 more pictures have been added. So look at what I've drawn here. Here is 1/4, here is 2/3. And we know that, I'm going to break out my colored pen, that when this amount here, when literally, I'm going to take this off, scoot it over some, when 375 more pictures are added to this 1/4, you see that? Then it becomes 2/3 full. So what we know here is this, if I subtract 1/4 from this 2/3, I know that I'll get 375 pictures. Well, what is 2/3 take away 1/4? Well, showing you the computation here, because I'm trying to figure out this quantity here, because the difference between 2/3 and 1/4 is 375 pictures, and that's useful information. So I'm going to subtract those. I have to get common denominators, and look what I end up with. I end up with 5/12. Well, how does that help me? I know that 5/12 is equal to 375. So if I partition, we know that's been, if I divide that by 5, then I know what each of those 1/12 is. And I end up with 75. I know that if this is my memory here, am I on the screen? Yes. Let me see if I can do this. I can do this. 1, 2, 1, 2, 1, 2. That's all my memory. I have now found out that one of those is 75. That means, how many pictures can the memory card hold? 12 times 75 is, all of my memory is 900 pictures. How many pictures were originally on the card? Well, let's go back to the thing, to the word problem. A digital camera memory is 1/4 full. All right, so I want 1/4 of 900, which means I shouldn't write it that way. I want 1/4 times 900, and that gives me 225 pictures. Now that's a tough problem, so I'm going to go over it one more time and see if you can follow it. Here's what I did, and if you don't, that's okay. We're going to do this more. I know that I have 1/4 of the memory, so here that is 1 out of the 4. The card is 2/3 full, so I can know that here's 2/3 when there's 375 more pictures. So I know that the difference between 1/4 and 2/3 is 375. Well, how do I discover that? Well, the difference is subtraction. So look, I subtracted them. 2/3 take away 1/4. I have to have common denominators to do that. And so when I subtract, I get 5/12. So I know now that this quantity here is 5/12, the difference. Well, I also know that that is the same as 375. All right, well, so I took 375 and I divided it by 5. And that gave me 75. So that means each of those 1/12 units is 75. That took me to the overall memory. And that tells me that, well, to find all of them, I have to multiply it by 12, which gave me 900. And then 1/4, because now they want to know how many pictures were originally on the camera. Well, it says here 1/4. So 1/4 of 900 is 225.